M1 has got a mass of 10 kilograms, so we can easily say that it must have a weight of 10 times 9,8, which happens to be 98 newtons. So we can just hang on to that as a sideline for the moment. The block is positioned on a slope. The inclination is 20 degrees. The coefficients of static and kinetic friction are given, and to prevent the block sliding down, a force has been applied. Now, normally, if it were to stay there, it would also have to have a frictional force up there. Why? Because the weight is clearly going to be acting down the slope and into the slope. So then there's also a normal. We know that 20 degrees is over there. Then says, draw a labeled free body diagram of all the forces acting on M1. I personally like to put the slope in, but you don't have to. But you do have to say weight acts perpendicularly downwards. You then have to show the frictional force acting up, and you have to label it friction, or frictional force is even better. There is an applied force up this slope. Nothing's moved, so it's all still in balance, and there is a normal. And then it says it wants an angle, so best you put a little dotted line over there and stick 20 degrees in over there. Define the normal force. The normal force by definition is a perpendicular force acting on the surface. You need to write the whole thing out, of an object that the object is in contact with. So the normal is perpendicular force exerted by the surface on an object that it is in contact with. Calculate the normal force on M1. So the first thing we're going to do is we're going to have to draw ourselves a nice right angle triangle. That's my 98. I then have got a force acting down over here, which is going to be equivalent to my friction, but we can call it the parallel force, and a force acting up here, which we can call the perpendicular force, and we can put a 90 degree over there. We also know that that is 20 degrees over there. So that is opposite 20, that is adjacent to 20, and that is the hypotenuse of this triangle. So if I want to now calculate the normal force, I'm going to say, I've got my weight already, and I'm going to say that the normal is perpendicular, so it is going to be the adjacent, so I will go cos of 20 degrees is equal to my perpendicular that I don't know, divided by 98, and therefore the perpendicular turns out to be 92,09 newtons. And then the next, and it's perpendicular to the slope, there should be a newtons there, sorry. Show that the frictional force that acts on M1 when it is stationary is equal to whatever. So first I'm just going to quickly calculate out the parallel component, because hopefully that's it. Okay, so it's the opposite side, so I'm going to go sine of 20 degrees is equal to the parallel component divided by 98, and I find that that is going to be equal to 33,52. That did not help me at all. It certainly isn't 8,29. So I'm going to suddenly realize that actually there are two forces acting in the parallel direction. Let me try another method of finding friction. So I'm going to say the frictional force is equal to mu F normal, which is 0,09, because this whole thing is static. And so I need to use that first number, times by the 92,09 that I just worked out, and I land up with, oh goody, 8,29, and that's up the slope. Then it says, calculate the component of weight acting parallel to the slope. So actually I just did that earlier. Good news. So we've got that answer already. State Newton's first law of motion. We've got to know all of our definitions quite nicely. So Newton's first law of motion is that an object continues in the same, at rest, or in the same uniform motion, unless an unbalanced force acts on it. That reminds us that we have got to look for balanced forces. What is the minimum FA? So we know that we have got a total force. These two forces over here must equal the downward component of weight. So they are going to have to equal 33,52. 0.52 because everything's stationary. We know the friction is 8,29, so therefore the FA that we are going to be calculating over here is going to be equal to the entire force, which is 33,52, minus the frictional force, which is 8,29, and I land up with 25,23 newtons. A force FA of 100 newtons is now applied to the block so that it moves up the slope. The frictional force that the block experiences is 6,45. You could have worked that out because you could have used the kinetic friction over there and the kinetic frictional coefficient. Calculate the acceleration of the block. So the first thing I need to do is get the force resultant. Force resultant is equal to the big force, which is the 100 newtons that's being applied. At this point, something dramatic has happened. And that dramatic thing is that my frictional force, if I am now moving up the slope, this kinetic friction is actually acting down the slope because friction always acts against the motion. So I'm minus 6,45. And don't forget that I've also got, acting down the slope, a weight of 33,52, rather a component of weight, but part of the weight. And therefore, I'm left with a resultant force of 60,03 newtons. And I know that the mass of this block is 10, and force resultant is always ma, and therefore my acceleration turns out to be 6 meters per second squared up the slope.